Good afternoon. So today we want to demonstrate a test case that we tested recently in Berlin with one brand new feature about SRv6 L3VPN active multi-homing. We tested that with the three vendors, Cisco, Nokia as PE routers, and Keysight on C routers for traffic generation. So let's talk a bit about test purpose. So we will demonstrate here the EVPN-based all active multi-homing for L3VPN services. As you know, we used for decades EVPN with multi-homing active standby, but for level 2 services. Now we have an extension, very useful extension, if you ask me, for L3 VPNs. So we're going to show the ARP and ND synchronization between two P nodes as a multi-homing for C. And we use SRv6 as a transport, but it could also be used with SRMPLS or VXLAN. So a little bit of theory. Let's look at this very simple topology. There is a C, there is two PE, and C connected to these two PEs with a lag. So it is not aware that this is a multi-homing. It knows that, okay, we should know IP gateway and MAC address. So the obvious scenario is, okay, let's create on the L3 interfaces the same IP address and the same MAC address. In this case, at any case that C wants to send the traffic, it doesn't matter to which lag member. Well, that's very obvious, but why nobody uses it in the real networks? The problem is here for downstream traffic. Say we have one IP packet that arrives for C. Next step, P sends the ARP request. ARP request is sent. C is answering, but again, this is a lag. There could be some hashing. And it's possible that ARP request goes to the other lag member. In this case, the ARP is known on P2, but not on P1. So, meaning that the traffic coming here will be just dropped, because P1 does not know the ARP result for IP MAC binding. Usually, we use the L2 service with VRRP. That's possible, but you know, L2 service gives something like possibility of layer 2 loops, and VRRP can cause some scaling issues. With this new feature, we have the same situation, ARP request, ARP reply to another PE, but then we use EVPN for synchronization of this ARP table. And here, this IP MAC binding is known to both PE, and traffic is running. Now I give the stage to my colleague Deepak, who will give you more information about test setup.
Perfect. Thank you, Victor. So we've seen enough theory, so we'll directly jump into the lab demo. So this is the topology which we're going to work with. So this is the one which Cisco tested with Nokia in the EANTC 26. So the PE routers, what you see in this topology, are the Cisco and the Nokia multi-home PE routers. So for the Cisco PEs and all the Cisco routers, you know, we are using our latest Cisco 8000 product family. And for the Nokia, it's the Nokia 7750. So the main routers, the devices under test in this topology are going to be the PE1 and PE2. And you have a CE where we have an L3 multi-home lag to the PE1 and PE2. And we have a remote PE, you know, to basically, you know, send traffic to between the CEs and the PEs, right? So the whole idea is, you know, multi-homing is a layer 2 technology when we usually use it with EVPN, and we have to usually rely on IRBs or BVIs. And it's a bit of a complicated thing to implement. So this is a simple L3 lag where you have your L3 VPN interfaces on the axis. And we do L3 multi-homing. And the whole idea, like what Victor mentioned, is we're going to run EVPN synchronization between the PE routers so that your adjacency information, your ARP and ND information is synchronized between the PE routers. And the best thing is we have the SRv6 transport. So we use SRv6 microSID for the traffic forwarding. So we have the ISIS SRv6 enabled. So we're using the UDT46 to exchange it as L3 VPN route. So as soon as your adjacency is resolved on the PE interfaces, the route goes as with the SRv6 SID to the remote PE. The remote PE, the PE3 is going to program it as the multipath route on the remote, so it can hash traffic to either of them, right? So and it also helps with the fast reroute and stuff when one of your CEP link goes down, right? So that's the idea of the demo. So let me get into the routers. Okay. So this is your CE router, which is actually multi-home to both the PE routers. And the bundle which we are working on, the lag interface which we are working on, is this bundle Ether 1001. You see two interfaces. The first one is connected to the Cisco. The second one, the 08, is connected to the Nokia. And you can see these are all the L3 interfaces configured on the CE side. And I'm going to work with this particular sub interface, which is connected to an L3 VRF on the PE routers. Okay. And you can see, yeah, so this is the configuration, and I already have my end-to-end, ICMP traffic going on. And you can see, all the traffic, is mostly taking the Nokia link, and we also tested the load balancing, so it was also hashing across, right? So now coming to the important things, right? So if you look at the PE routers, I'm going to show from a Cisco perspective, and my friend Victor is going to show from a Nokia perspective. So the idea is simple. If you see the EVPN configs, if you're aware of the Cisco's XR configs, we create a bundle and we have an ESI ID. And this ESI ID is what we synchronize between the multi-home PEs. So, basically, EVPN uses the type 4 for the Ethernet segment and for the multi-home discovery, and and then we use the type 2 routes to advertise the MAC IP between the Cisco and Nokia, right? The MAC IP synchronization or the ARP synchronization, and how we kind of without configuring. So here, like I told you, we are not doing a MAC VRF or we are not doing IRB. So we are using your regular L3 VPN configuration, but we have a knob to synchronize it between the L3 VPN and EVPN using the EVPN round sync knob. And the way to see it is, if you look at the carving details, so the 10.00.35 is the Nokia PE and 10.00.248 is the Cisco PE, and we are able to form the L3 multi-homing on this particular Ethernet segment ID. So this is the ESI ID which we synchronize between Cisco and Nokia, and we run in a multi-homing all active mode, right? And you also can see we also we got the type 4 route from the Nokia for the the multi-home interface or the bundle, and we also received the type 2 routes which will have the MAC IP information to synchronize your ARP and ND. So these are my CE addresses, like the 172.51 network along with the MAC address, both IPv4, IPv6, link local. We exchange it as type 2 between the multi-home PE routers. And we use this information to do ARP synchronization, so you can see the route synchronization. I mean, usually, EVPN does the route synchronization with type 2. So the same is, applicable for the multi-homing as well. And if I go to the remote PE, I can show you. So basically, the remote PE receives it as a VPN v4 route or a VPN v6 route. And this particular destination is both received from Nokia and Cisco. And if you notice our forwarding output, you can see the microSID adjacency programming, the microSID programming for these routes. So this is the locator to reach the SID, and this is my UDT46 SID. And similarly, Nokia's locator is 2035, and the E069 is the UDT46 SID. And I would invite Victor to show the outputs on the Nokia.
Yeah, let's move to Nokia terminal. Basically, configuration is also pretty simple. In service, we should configure, of course, Ethernet segment. Configuration is pretty much the same as like a traditional Ethernet VPN for Ethernet segment for L3VPN, and the only difference that we should mention here, that here is a layer 3 neighbor synchronization, meaning that we don't use some L2 information, but we use it specifically for L3 with IP and MAC. So then the next step, just we should assign this to VPN service. And voila, with this configuration part, it gives the ARP and ND synchronization between the peer node that we have. Let's check a bit what we have with the ARP status now. So you can see that there is one the local address bound mapped to this MAC, and we received the ARP request, ARP reply from Keysight with this IP and this MAC. And you can see here that this ARP request came from C device, directly from interface. What is different is now is that we send this information to Cisco router, to peer PE, for synchronization. We use this for BGP routes. And you see that we are sending three addresses, IPv4 that assigned on our that we got from C router, IPv6, and the link local address for IPv6. So basically, that's it from my side. Let's do the test.
So we'll be shutting the link which the traffic is actively taking, and then we're going to show you the fast convergence as well, just in terms of traffic test. Yeah, so you see just one single packet drop and it converges faster, and the remote P is eventually going to just program it out of one of the guys. So it's only now pointing to the Cisco. So yeah, so that's about the convergence, and the no shut is going to also bring it back faster. Yeah. So that's about the demo. Thank you.